vector. Vector. Introduction. The temperature of the air around you has no particular direction. It is a scalar quantity. The force of gravity acts downwards on you. It has a particular direction and is a vector quantity. Speed is a measurement of motion that does not specify direction. It is a scalar quantity. Velocity is also a measurement of motion using the same units as speed, but with specified direction. It is a vector quantity. You are already very familiar with the rules of addition, multiplication, and so on that apply to scalar quantities. However, addition and multiplication of quantities with direction are not always quite the same. In this lesson, you will learn to distinguish between vector and scalar quantities. Calculate pairs of perpendicular components of a vector. Learn to add vectors in 1 and 2 dimensions. Consider components of a vector in 3 dimensions. Learn about the dot product of a vector. Learn about the cross product of a vector. Click on the map of the water to see the distance the boat travels and its final displacement from the starting point. The distance the boat travels has no particular direction. It is a scalar quantity. However, if we quantify both size and direction, then we are considering the displacement of the boat rather than its distance. Displacement is a vector quantity. Note that distance and displacement are not the same. Click Reset and click on the water again to see distance and displacement for another journey. Look at the labels in the bottom right of the screen. Drag and drop each label to the correct list below, either scalar or vector. Click Play button to start the boat. Click Components button and notice that route A and route B both result in the same final displacement. Both routes also have two perpendicular components, one in the x direction and one in the y direction. Let's call the vector S. Now we can say that the components of vector S in the x and y directions are Sx and Sy. Look at the formulae for sin theta and cos theta. Rearrange each formula by dragging and dropping sin theta and S and then cos theta and S to create formulae for working out Sy and Sx, respectively. Now calculate the values of Sx and Sy, taking size as 150 meter and direction theta as 30 degrees. Use values given to 2 decimal places for sin theta and cos theta, or use your calculator for greater accuracy. Now click Compare to check your answers. Click Reset button and select new values for the size and direction of vector S. Click Play button to see the displacement and calculate the new values of Sx and Sy. Now click Compare to check your answers. Repeat this process until you can confidently calculate components of a vector in x and y directions. Look at this boat's displacement shown in black for a journey from a starting point. Click Circular Motion to see the speed and velocity of the boat for a different motion. For a body in circular motion, speed may be constant, but direction is continuously changing. Therefore, velocity is continuously changing. Click Quiz and answer the questions about speed and velocity. Summary: quantities may be vectors or scalar. Vectors have specified direction as well as size. The length of the vector represents the size of the quantity, and the direction can be measured as an angle. When studying motion, displacement, velocity, acceleration, and force are all vector quantities. A vector may be made up of two perpendicular components, one in the x direction and one in the y direction. If a vector S has an angle theta with one of these components, then the two components are S sin theta and S cos theta. Now you can see an enlarged view of the boat. The boat has a velocity Vb due to its engine and a velocity Vw due to the flow of the river. These velocities can be added together to find the actual velocity with which the boat moves. This is called the resultant velocity, Vr. Look at the right-hand side of the diagram. Calculate the resultant velocity of the boat using the values for Vb and Vw and enter your answer in the Vr box. Click Compare button to check your answer. Notice that Vb is positive and Vw is negative. This is because the boat is moving in the opposite direction to the flow of the river. Click Vectors. Notice that the vectors and hence The direction of the velocities are represented by arrows. Select new values for VB and VW. What motion of the boat would you expect to see? Calculate the resultant velocity and click Compare to check your answer. Repeat this process until you can confidently calculate resultant velocity. Here you will see vectors that do not act along the same line but do act in the same plane, coplanar, with an angle of 90 degrees between them, perpendicular. Click Play to start the boat. Watch the boat cross the river. There is no river current. Therefore, resultant velocity is equal to the velocity due to only the boat's engine. Velocity due to the boat's engine is Vb. Velocity due to the flow of water is Vw. The resultant velocity Vr can be found using Pythagoras theorem. Look at the right-hand side of the screen. Enter the values for Vb and Vw in the resultant velocity Vr equation and calculate the resultant velocity Vr. Click Compare to check your answer. Click Reset button and select a new value for velocity due to the flow of water, Vw. Click Play to start the boat. Select Vectors to see the vectors Vb, Vw and Vr. Enter the values for Vb and Vw in the resultant velocity Vr equation and calculate the resultant velocity Vr. Click Compare to check your answer. Click Reset button and select the value for velocity due to the boat's engine, Vb equals 0. Select Vectors button and click Play to start the boat. Enter the values for Vb, Vw and Vr in the resultant velocity Vr equation and calculate the resultant velocity Vr. Click Compare to check your answer. Try other values of Vb and Vw until you are confident with the addition of perpendicular vectors. Here you will see vectors that are in the same plane, with an angle between them which is not 90 degrees. Select Vectors and click Play to start the boat. Use the value for VB to calculate VB cos theta, the component of VB in the x direction, and VB sin theta, the component of VB in the y direction. Click Compare button to check your answers. What do you notice about the component of VB in the y direction and the water velocity VW? Answer: they are equal in size but opposite in direction. So one is positive and the other is negative. Click Reset button and select VW equals -3 meter per second and VB equals 5 meter per second. Click Play button to start the boat and calculate the components of VB. Click Compare button to check your answers. Why did the boat fail to reach its destination? Answer: the component of VB in the y direction does not equal VW. Click Reset button and try to select a value for VB so that the boat makes a successful journey. Now click Play button to start the boat and see if its journey is successful. Calculate the components of VB and click Compare button to check your answers. Click Reset button and select a new value for theta. Now select new values for VB and VW to make a successful journey and calculate the components of VB again. What do you notice about successful journeys? Answer: successful journeys are possible when the total velocity in the y direction is 0 or very close to 0. Summary: a vector may be represented by an arrow. The answer to addition of vectors is called their resultant. Vectors acting in one dimension in a single straight line can be added in the same way as scalar quantities. However, for perpendicular vectors acting in two dimensions in a single plane with an angle of 90 degrees between them, the resultant can be found using Pythagoras' theorem. For non-perpendicular vectors, choose one vector and find components which are parallel and perpendicular to the other. Then add the parallel components as vectors acting in one dimension, as above. Finally, find the resultant by using Pythagoras' theorem as for perpendicular vectors.